All right, so welcome to the the spring 2013 exam review, where I'm actually covering the fall 2013 exam. Now, just to remind you guys, most of you guys actually in here took Calculus 1 with us, so you know the pattern. It's a three-part exam. The first part is a no calculator multiple choice. The second part is a multiple choice with a calculator, and the third part is free response with the calculator. But here's how it works. You will be given your exam. You are allowed to open up the first part right at the get-go, and you're going to be working on that. But you're not allowed to use your calculator. No one's allowed to use a calculator for the first hour of the exam. Not until your professor gives you the official word that, okay, everybody's turned in part 1, now you can have your calculator. And you must complete part 1 within 1 hour. So the exam starts promptly at 8. That's why you got to be at the exam at 7:30 to fill out all these forms. And then at 8 o'clock, you open your test booklet. So we're going to start our test booklet, no calculator, so the calculator's put away. And so here we go. Open up the test, and now this is Calculus 2. What do you think the majority of the questions they're going to put on the no calculator section of the exam? Integrals. Probably something like 40% of this exam is going to be integrals. So here we go. First problem. And look, it's even got integral with bounds. So we do expect you guys to have the ability to work basic numbers. They don't have to be overly difficult or anything like that. So the first integral is this. The integral from 1 to 2 of 4x cubed dx. Well, this is about as easy as it gets, and we always try to start you out. The first question is going to be probably the easiest of the calculus questions. So you've got to integrate this thing. The integral of 4x cubed, 4 is a constant, leave it alone. Integral of x cubed is x to the 4th over 4. They cancel, but it's no plus c because we got bounds, so it's a definite integral. Evaluated from 1 to 2. According to the fundamental theorem of calculus, we plug in top, minus plug in bottom. And now we got to figure out some numbers. What's 2 to the 4th? 2 times 2 times 2 times 2. What's that? 16. 1 to the 4th is just 1. So 16 minus 1 is 15. Answer's B. Question number 2. Again, looking for patterns. Do expect a lot of basic integrals on the first one. U substitution is going to hit you hard on that. Integration by parts, partial fractions. Those are the classic techniques of integration that we quizzed you guys on. There'll be some tables in the back, table questions too. But in terms of knowledge that we expect you guys to know, number 1 is that U substitution with those basic rules memorized. Here's another basic rule right here. What's the integral of 2 e to the x plus x dx? Well, 2 is constant, leave it alone. The integral of e to the x is e to the x plus the integral of x to the first power is, add 1 over add 1, x squared over 2. No bounds on this one, so I get a plus c. So which one is this one going to be? 2 e to the x squared over 2 plus c. Answer is E. So far, so good. Now the next one, remember, never forget John's Fundamental Theorem of Calculus. It's going to help you out immensely all over this exam. Clean up your algebra first. You see this problem right here, the integral from 1 to 2 of 1 over u squared du? You'll be amazed how many students that I have seen throughout the years on the final exam would tell me the integral of 1 over u squared du is clearly the natural log of u squared. And you have violated 45 rules of math. No, the integral of 1 over u du is natural log, absolute value of u. The integral of 1 over u squared, you had to clean them up first. I don't do things that are square or any kind of power in the denominator. So this would be the integral from 1 to 2 of u to the negative 2 du. Now integrate with the classic power rule, add 1 over add 1. That'll be add 1, negative 2 plus 1 is negative 1. That'll be u to negative 1 over negative 1, evaluated from 1 to 2. Back to bring it up. Negative exponent goes on the bottom, divided by negative 1 makes it negative 1 over u, evaluated from 1 to 2. And then you've got to apply your fundamental theorem of calculus. Basically plug in top, negative 1/2 minus plug in bottom, negative 1 over 1. Plug in top minus plug in bottom. Well, take your time. You've got an hour to do this first part. Enjoy it. So take your time, because most students will screw this stuff up by stupid, careless errors. And so you got negative 1/2. A minus is a plus 1. Negative 1/2 plus 1 is positive 1/2. But you understand, one false, careless error will screw it up, so pay attention. Remember, no calculators on this part. So the answer is D. Find the area of the region bounded above by the graph y equals 3 square root of x and below by the x-axis. All right? Again, we have no calculators, but you still need to get a visual perspective on this. Again, this is the first part of the test, so they're not going to be giving you overly exotic equations, but it's basic equations you should know. For example, y equals 3 square root of x. What does the square root of x look like? Start at the origin, bows out. Okay? There's y equals 3 square root of x. And the x-axis, well, that's real easy. There's my x-axis right here. Evaluate it between 0 and 1. What they're talking about is the area of this region. Again, one of those concepts you definitely need to know for the exam, and that is area between two curves. How do you find the area between two curves? Top minus bottom, integral of top minus bottom dx. Or integral right minus left dy. But clearly we have a distinct top and a distinct bottom here. So this would be the integral of 3 square root of x, officially top minus bottom, 0 dx, for my bounds for x running between 0 and 1. Well, of course, you want to clean this up. This is the integral of 3x to the 1/2 dx, evaluated from 0 to 1. 3 is a constant, leave it alone. Integral x to the half, add 1 over add 1 is x to the 3/2 over 3/2, evaluated from 0 to 1. But of course, you want to clean it up. When you divide by a fraction, you invert and multiply. So dividing by 3/2 is the same thing as multiplying by 2/3. Times the 3's cancel, you're left with 2x to the 3/2, evaluated from 0 to 1. Again, watch the careless errors. That's going to be key on this exam. That's where most students will make stupid mistakes, and enough stupid mistakes makes this a horrible, horrible grade. So, plug in top minus plug in bottom. This will be 2 times 1 to the 3/2 minus 2 times 0 to the 3/2. Well, that's not too bad there. So, and now, what's 1 to any power? 1, and what's 0 to any power? 0. So pretty much, what do I get here? That's 1, that's 0, so that goes away. So it's 1 times 2, which is 2. The answer is 2. The answer is D. Does that make sense? And notice, I did not need a calculator. But notice the first 4 problems. Integral, 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 integral. What a surprise. What are the other types of easy questions they can give you guys in terms of no calculator type stuff? Well, what about sequences and series? Take a look at these two guys. Luckily, you just recently had a test on this, so this should be the most recent and fresh stuff in your memory. This is a sequence. The sequence A sub n, where A of n is equal to 1 over 2m plus 1. All right? You want to figure out, obviously by looking at the answers, converges, 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 or diverges here. Is it converge or diverge? Now remember, this is where students will screw this up at. This is a sequence. How do you tell if a sequence converges or diverges? You just take the limit as n approaches infinity. Be amazed how many people tell me this thing diverges by the harmonic series. It's not a series at all. Where do you see a sum in front of this thing? Pay attention. Watch for careless errors. It's little stuff like that that you're not paying attention will kill you on this exam. This is a sequence. To do a sequence, you take the limit as n approaches infinity of 1 over 2m plus 1. You throw in infinity, so when I plug it in, this is 1 over 2 times infinity is infinity plus 1 is bigger infinity. And when the infinity is on the bottom, what's the answer? 0. So this thing is A, converges to 0. Does that make sense? Look at the next one. Now the next one, that is a series. That's different. Now, I keep telling students about, in my class, you know, you've had 7 tests you're supposed to have memorized. The divergence test, the integral test, the direct comparison test, the limit comparison test, the alternating series test, the ratio test, the root test. There's tons of series you guys are supposed to have memorized. But There are lots of tests. There's only one answer, but there's lots of tests I can use. You see this guy right here? In terms of a series, I can tell you exactly what this thing does, and you should too. I'm doing a mental comparison test. What does the sum as n goes from 1 to infinity of 1 over 2n plus 1 look like? It looks like pretty much 1 over n. I don't care about numbers. I care about the n stuff. It's 1 over n. And this is a sum. Sum of 1 over n, that's harmonic series. And what does the harmonic series do? Diverge. This is called the mental comparison test. I'm just looking at it and figuring out what I would compare it to. I would compare it to the harmonic series, which diverges. The answer is divergent. So I'm done. However, here's the deal. There's lots of different tests I could have used on this thing. I could use a limit comparison test. I don't think I could use the direct comparison test because I couldn't get my inequality the right way. You know, adding 1 to the denominator makes the denominator bigger, overall fraction smaller, and I'm trying to compare to this harmonic series, and like you said, the harmonic series does what? It diverges, but I can't get the inequality right way, so I would either use the limit comparison test, or I could have used integral test. Remember, this is calculus 2. If you can integrate, turn that series into an integral. If you can integrate it, that's always an option. If the integral diverges, the series diverges. Integral converges, the series converges. That's called the integral test. I would not use the ratio test on this thing or anything like that. So, and obviously I would not use the alternating series test because it doesn't alternate. So you got to outthink these kind of problems. But there are two different ways I could have tested this thing, but the answer is still the same. What is it? Diverges. Answer C.
Why wouldn't you use?
Why wouldn't I use?
Why wouldn't you use the alternating series test?
Oh, question. Why would I not use the alternating series test? To use the alternating series test, I'm going to throw it in your face. What kind of series do you have to have? Alternating. What defines an alternating series? It's either going to look like -1 to the n, or n plus 1 or n minus 1, or cosine of pi n. Remember that old famous looking alternating. There's no -1 to the n on this problem. There's no cosine of pi n on this problem. This thing's not alternating. That's nice and positive. So it's either got to be the limit comparison test or an integral test that I would officially do. Yeah?
I don't understand why the series 1 over n diverges or the series 1 over n squared converges.
Called a P series. What's the standard P series? When P is greater than or equal to 1, excuse me, let's get it right. When P is less than or equal to 1, the P series diverges. When P is greater than 1, it converges. It comes from the integral test. The reason why is this. What's the integral of 1 over x dx? Going from, let's say, 1 to infinity. I'm turning my series into an integral. What's the integral of that guy? Natural log, absolute value of x, evaluated from 1 to infinity. I'm not going to write it up fancy. I'm just going to throw in, it's an improper integral, I know that. But this will be the natural log of infinity minus the natural log of 1. What's the natural log of infinity? Infinity minus natural log of 1 is 0. Infinity minus 0 is infinity, which means it diverges. So if this diverges, this series diverges. That's the harmonic series. However, if you wanted to say 1 over n squared, that's a P series. P equals what? What's it going to do? If I have to prove it, I'm going to integrate from, let's say, 1 to infinity of 1 over x squared dx. Well, that one you have to clean it up. This is the integral of x to the negative 2 dx from 1 to infinity. Add 1 over add 1. This will be negative 1 over x when you integrate it. Evaluated from 1 to infinity. Plug in top minus 1 over infinity. Plug in bottom minus negative 1 over 1. But 1 over infinity goes to what? 0. Minus minus is a positive 1. This thing actually, you get a number out of it. It converges to 1. So when the integral converges, what's the series going to do? Converge. That's where the P series is coming from. And that's why it works. All right. Take a look at the next page. All right. Consider the graph of the function. Interesting function here. We've got this weird function horizontally out and then dropping off here. Y equals f of x. Which of the following best approximates the integral from 0 to 1 of f of x dx? This is the type of question that freaks people out because they look at it and they don't know what to do. Here's what you do. When you got an integral and they're doing pictures, number one, what is the integral dealing with the picture? You've been programmed. It's the area under the curve. And here's the deal. When you look at a problem like this, you want to go to your basic definitions. How do you first learn integrals? Riemann sums. So make it a big old Riemann sum. Well, they didn't give me any kind of inner on this thing. Well, not a problem here. We're going to make some rectangles out of this guy. So if I want to approximate this integral dx can be approximated because this thing just goes over here and drops off. So if I make a rectangle out of this thing, kind of a Riemann sum, I get something like this, right? And so now I'm trying to approximate this guy. Which one is best approximates this particular function here? All right? Well, first off, this is a rectangle. So I can tell you this is the area under the curve. Here's my area. So this would be, well, hello, area is between length times width, which is, 1 times 1, which is 1. So I know this thing is less than 1. And let you guys know, if you guys didn't know, this is my daughter. Thank you, sweetie. Is Mommy sending you over here to me?
Mm-hmm.
Uh-huh. Okay. What do you want me to do with these? Do you want to make an announcement since you're here?
Yeah.
For my section 7 and 8 test scores, pick them up before you go. Use those problems to study. Okay?
Okay, so I'm going to leave them up here so you guys can attack them after class.
Ms. Taylor, where's our test? Because on Moodle it's McHenry, and you said in classes it's Virgin.
No, you guys are in version 110. What does it say on Google? I'm sorry, I want to say it is version 110.
Sure. All right. And let you guys know, this is my daughter's hand being recorded. Outstanding. Good job, babe. Okay. All right. Oh, yeah. Where were we at? Oh, yeah. Area under curve. Remember that one? All right. So, I know the area has to be what? Less than 1 by the basic rectangle Riemann sum. How much less than 1? It's not going to be much less than 1. So, look at your answers. This is one of those, it's kind of obvious if you know what you're doing type thing here. This thing is close to 1, but see that little gap that's missing there? That's a very small fraction of it. So what number up here is close to 1 but slightly less than 1? Answer C. Does that make sense? It can't be 1.5 or 2. That's way too much. 2.2 is too little. And 0, no, there's really some area there. So that's not going to be 0 either. So it's one of those kind of problems. But again, don't be frustrated by the exam. There's got to be some kind of logic thing. Sit back, take a breath, and look at it. And remember, area under curve, and look at rectangles, length times width. Do some geometry to this thing. All right? What kind of series is this guy? The sum is n goes from 0 to infinity of 2 raised to the 2n plus 1 divided by 3 to the n. There's a couple of different ways you can go about doing this particular problem. First off, you've got to recognize this series. What kind of series is that? I got nothing but numbers raised to powers of n, and I'm adding them up. What do you call it? Geometric series. They did something nice for you guys on this one. And what did they do that was nice? Was they wrote it out for you guys. When they write it out, it's easier to analyze the geometric series. Now, if I just give you the formula, I can actually manipulate the formula to try to make it look like one of the problems there. Okay? But in this particular one, here we go. When you have it written out, so I'm going to show you both ways how to do this problem. When they have a geometric series written out, A is always the first term. So what's A in this problem? 2. R is what you need to multiply by the first term to get to the second term. What do I need to multiply a 2 by to get to a 4/3? 2/3. And they always write out at least a couple of them to be able to double check that R. What do I need to multiply by 4/3 to get to an 8/9? Another 2/3. So that makes R equal to 2/3. Geometric series, as you just stated. So with the geometric series, we notice the absolute value of R is 2/3, which is less than 1. And what is the formula you have memorized for the geometric series? Converges to A over 1 minus R. This is 2 divided by 1 minus 2/3. Easy math here. This is 2 divided by 1 minus 2/3 is 1/3. And 2 divided by 1/3 is 6. It converges to 6. The answer is D. However, because this is a review for your exam, I'm going to show you the other way, just in case they didn't write out the terms. If they just gave you this, The sum as n goes from 0 to infinity of 2 to the n plus 1 over 3 to the n. There are actually two different ways I could manipulate the formula. The first one is this. Your basic chapter 8.2 formula is the sum as n goes from 1 to infinity of a r to the n minus 1. This was the original geometric series that we started you guys out on. But there was a pattern. And the pattern was this. I have to start this thing out at 1. Since I'm starting out at 0, what I want to do here is I want to add 1 to the summation to make it start out on the right foot. Does that make sense? But what was the algebra? This is what I wanted to go over. What is the algebra on your summation if you have to add 1 to the sum at the bottom? What do you have to do inside? Subtract 1. Equal but opposite maneuver. So each n is going to be, you get to subtract 1. So this is going to be equal to the sum as n goes from 1 to infinity of 2 raised to the n minus 1 plus 1. That's just 2 to the n because the minus 1 plus 1 cancels there. And this will be divided by 3 to the n minus 1. What power do I want on my r's on this thing? N minus 1. Look at that numerator power. I got 2 to the n. I got too many of them. How many too many do I have? 1 too many. So I'm going to pull one of them off. So this is the sum as n goes from 1 to infinity of 2 times 2 to the n minus 1 over 3 to the n minus 1. And again, I'm trying to go over detailed in terms of explaining this stuff. So this is the sum as n goes from 1 to infinity of 2 times 2/3 to the n minus 1. Now you've got it written in the proper format. What's a equal to? 2. What's r equal to? 2/3. And I'm right back to where I started from and plugging it into my formula. Does that make sense? The other way is this. This right here was the chapter 8.2 way of doing geometric series. The sum as n goes from 1 to infinity of a r to the n minus 1. When you guys got into chapter 8.6, I believe it was, you were introduced to a new and improved version of the geometric series because it looks better when you did power series on it, which was this. The sum as n goes from 0 to infinity of a r, but it was raised to the what? N power. These two guys are the same thing. This one looks better when you do power series. This one looks better when you're actually trying to count out the terms. Two different ways of looking at it. So this one did start out, if you look at this problem, the sum as n goes from 0 to infinity of 2 to the n plus 1 over 3 to the n. That was the original problem up there. Now, you've got the summation start out in the right spot, but you want a power of n. That's got 2 to the n plus 1. Again, you got 1, 2 too many. So pull off one of the 2's. That gives you 2 times, and it'll be 2 to the n over 3 to the n, which makes it the sum as n goes from 0 to infinity of 2 raised to 2/3 to the n. Again, a would be 2, r would be 2/3, and I'm back to using my formula to get this guy. 3 different ways of doing this particular problem, but again, in classic math, there's only one answer. Okay? So remember all 3 geometric series type of ways of doing this particular problem. Look at the next one. Next one is this. The sum of the integral of the sine of t times the cosine of t dt. What method of integration would you use to integrate this guy? It's not going to take long for them to jump on a u substitution problem. But the trick is this. What would you let u equal to? Well, I always want to let u equal to something so when I take its derivative is also in the problem. Well, honestly I could let u be either one. I could let u equal sine of t, or I could let u equal cosine of t. It's honestly up to you guys, but there's one that's more logical than the other, and we're after you guys learning this concept too. So if I'm doing u substitution, personally, I would let u equal to sine of t. Why the sine of t versus the cosine of t? What's the derivative of sine of t? Cosine of t dt, which is in the problem. And I didn't have to maneuver a constant. If you wanted to be abstinent and be able to sit there and let u equal cosine of t, that's fine. But then what's the derivative of cosine of t? Negative sine of t. Then you have to move the negative to the other side, and you got an extra negative floating around in this problem. And I don't like that one. Why? Because I don't see negatives on my answers anywhere. That's really what I'm always keeping in the back of my mind. I'm looking at my answer choices, the strategy on doing multiple choice tests. So this is the way I believe they wanted you to do it. So when I converted this thing over, this would be the integral. The sine of t was u. The cosine of t dt is the du. What's the integral of u to the first du? U squared over 2 plus c. And what was u equal to? U was equal to, sine of t. U was equal to the sine of t squared over 2 plus c. But however, that sine of t quantity squared is the proper way of writing it, but they wrote it in the lazy man math. So sine squared of t, sine of t quantity squared means we write it as sine squared t over 2 plus c. And the answer is clearly B. Does that make sense? Again, why didn't I let u equal cosine of t? Honestly, it's the du with a negative, and I didn't see negatives in my answer. That would have been also an equivalent answer that way. All right. Speaking of u substitution, take a look at this next guy. The integral of x squared cosine of x cubed dx. What technique of integration would you do on this guy? U substitution. And the number one technique of U substitution is you let U equal inside the parentheses. Basically, when it comes to trig, you only let U equal angle, which is x cubed. What's du? The derivative of x cubed is 3x squared dx. Move your constant to the side. 1/3 du is equal to x squared dx, which is in the problem, so I know I'm on the right track. So when I now substitute, this would be the integral. This is the cosine function that stays. The angle was now u, and the x squared dx gets replaced with 1/3 du. 1/3 being a constant goes out front. We always put the d stuff in the back. So far, so good. Now, pure memorization, and remember this. They're going to try to mess you up on these answers for the final exam type thing here by making sure you have the proper formula memorized. What is the integral of cosine of u? Which one is it? Negative sign or positive sign? That's what worries me. I hear 1/3 of people saying negative, 2/3 of people saying positive. Remember, the derivative of sine is cosine, therefore the integral of cosine is sine. So it's actually positive sine. So 1/3 the positive sine of u, no bounds on this thing, plus c. So this is 1/3 the sine of x cubed plus c, which is, which one of my answers there? 1/3 x cubed plus c. Looks like the answer is what? A. Does that make sense? I would not do integration by parts on this one. You only use integration by parts if two things. One, U substitution doesn't work, and two, it's a product. Okay? So, this clearly the answer is A on this one. And honestly, I'm surprised by the people who made up the final exam on this one. 99.9% of the time, they'll write the answer 1/3 sine of x cubed plus c, and the answer B would be negative 1/3 the sine of x cubed plus c. They always love to do that stuff to you, just to see if they can get you to jump in through the wrong hole. Does that make sense? Pay attention to signs. Make sure you got that stuff down. Now, speaking of this guy, and I'm talking to all students, but especially my students, if you have caught a pattern throughout my test and my exams, and the material that I've covered in class, when it came to integration by parts, there has been several problems that we just continuously beat you guys up with, that you automatically know it's integration by parts. It's the classic x times e to the x, got to go by parts. X times sine of 3x, the integral of x times the cosine of 2x. That x cosine or sine of kx, look, that's integration by parts guy. The classic x e to the x integration by parts. And again, showing your work. Remember, there's no calculator. I know you TI-89 fans out there that love this problem on the old exam, but it's not going to be on any kind of part without that's going to have a calculator, because it's too easy just to type in the numbers with bounds. Any calculator will do that. Any scientific calculator, that is, these days. But this one, to show your work, you've got to do integration by parts. Integral of e to the x, x times e to the x dx, evaluated from 0 to 1. Before I do the 0 to 1, I'm just going to integrate this guy. But you've got to remember your parts formula. The integration by parts is the form integral of u dv equals uv minus integral of v du. Okay? What would you let u equal to? You always want to let u equal to, quote unquote, the part you want to get rid of. You don't get rid of e's in problems. You get rid of things through derivatives or integrals. The fact is, I would let u equal x. Therefore, what's du? Derivative of x is just 1 what? Dx. That means the rest of it has to be the dv part. The dv would be e to the x dx. And what do you got to do to dv to get back to v? Integrating. What's the integral of e to the x dx? E to the x. We don't put plus c's until the very end of the problem here. So this will actually turn into the integral of u times v minus the integral of v du. U times v is x e to the x minus the integral of v, which is e to the x du, which is equal to 1 dx. What is the integral of e to the x dx? So this is x e to the x minus e to the x. No reason for plus c's because we had bounds on this thing. The bounds were from 0 to 1, according to the fundamental theorem of calculus. And be careful. Right here is where I saw students last semester fall apart. And it wasn't, I mean, they did some beautiful calculus, and they couldn't figure out the number without a calculator. Take your time in plugging in your numbers. Fundamental theorem of calculus, plug in top. This would be 1 times e to the first minus e to the first minus plug in 0. 0 times e to the 0 minus e to the 0. Parentheses around plug in top minus parentheses around plug in bottom. Right here's where they fell apart. Couldn't pull it off and figuring out what the answer is and making it match up to one of these guys. What's e to the first power? Anything to the first power. What's that? E times 1 is still e, so this is e minus parentheses. What's 0 times anybody? 0 minus, what's e to the first, the 0 power? 1. Anything to the 0 power is 1. All right, so here it goes. What's e minus e? 2.7 minus 2.7, that's 0. But you do have to distribute this negative. So this is 0 minus 0 plus 1. What do you get? The answer is positive 1. The answer is D. But it was the careless error that caused them to circle answers like 2e minus 1 and stuff like that. Be careful. Watch the careless errors. All right. Suppose that the function f satisfies f prime of x is equal to 4e to the 2x and f of 0 equals 3. Then find f of 1. Honestly, this was from chapter 5.1, actually 4.7 from Calculus 1 kind of question here. You were given the derivative and asked about the function. This is the basic idea behind the antiderivative or integral. So to figure out what the function is, you need to integrate the derivative. We're going to integrate 4e to the 2x dx. This guy, you can use U substitution on it, but it's a shame if you have to do that. This is one of those special forms that you're supposed to have memorized. It's going to help you out immensely on the final exam, knowing these basic formulas. And these were the basic formulas over here. It was the famous integral of e to the kx dx, the integral of the cosine of kx dx, and the integral of the sine of kx dx. These are the special U substitution. I know the formula, so I don't have to do anything. Problems you were supposed to have memorized from chapter 5.5. What's the integral e to kx dx? It's 1 over k e to the kx plus c. What's the integral of the cosine of kx? 1 over k, integral of cosine is sine of kx plus c. And the last one you're supposed to have memorized, so this is just trying to remind you as I'm reviewing you guys for the final exam. The integral of sine of kx dx is negative 1 over k cosine of kx plus c. That's designed to really help you out because this was clearly one of the first problems here. 4 is a constant. Leave it alone. What's the integral of e to the 2x dx? That's going to be 1 over 2 e to the 2x plus c. Clean it up. Your f of x is equal to 4 divided by 2 is 2 e to the 2x plus c. But now you've got to figure out the exact value. They gave you an initial condition. Initial conditions designed to figure out what the c has to be. So I'm going to plug in f of 0. That'll be 2e to the 2 times 0 plus c and set it equal to 3. 2 times 0 is 0. E to the 0 is 1. So this is going to give you 2 plus c equals 3. Subtract 2 from both sides. What's c equal to? 1. Therefore, your answer for f of x is equal to 2e to the 2x plus 1. But that's not the question. One more hoop to jump through to figure out what the question is. What do they want me to find? F of what? 1. We wanted to find f of 1. So f of 1 would be equal to 2 times e to the 2 times 1 plus 1. So f of 1 is equal to 2e, 2 times 1 is 2, plus 1. So it's 2 times e squared plus 1, which is answer 2e squared plus 1. Answer is A. Another one of these things that frustrates students, that some problems take me 10 seconds or less. Other problems take me a few minutes because they keep adding these extra hoops that I have to jump through to be able to get to the answer. Does that make sense? All right. Keep on going. Still no calculator. The power series. Woohoo! The power series sums n goes from 0 to infinity to negative 1 to the n times x to the 2n is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Is the Maclaurin series for which guy? This was pure memorization. Did you memorize your Maclaurin series? Yes or no? If not, maybe next semester. If so, then this is an easy problem. Which one is it? Well, these guys are even problems. Even. Remember, when they're the odd powers, it's the sine function. When it's the even powers, it's the cosine function. They have factorials on them. The tangent doesn't have factorial on it. So which one is this one? It's cosine of x. These are the Maclaurin series you're supposed to have memorized. Which ones are you supposed to have memorized? E to the x, cosine of x, sine of x, arctangent of x. Those are the classic ones. Okay? And possibly even, let's see here, 1 over 1 minus x or something like that. You're supposed to have that memorized. All right. Take a look at the next guy. All right. This is a Chapter 5 question. Again, try reviewing for the final exam. This is why you never want to miss one of the review sessions, and why you never want to, why you do want to go over more exams than just this particular one. To remind you of questions like this. We got f of x is equal to the integral from 0 to 2x of the square root of 5 plus t squared dt. You're supposed to find f prime of 1. Before you find f prime of 1, you better find f prime of x. In other words, you want to take the derivative of the integral from 0 to 2x of the square root of 5 plus t squared dt. This was what that fundamental theorem of calculus part 2 we talked about in class. First fundamental theorem of calculus was you take the antiderivative, plug in top minus plug in bottom, and get the area under the curve. The second fundamental theorem of calculus was this idea of taking the derivative of the integral. And the derivative of the integral, they end up canceling each other out, and you just get the function. But I have something other than x on my bound, so I have to use the chain rule version of this guy. So my answer from the fundamental theorem of calculus is the derivative of the integral cancel, so I'm left with the square root of 5 plus, and instead of t, I'm going to plug in the bound value, 2x squared. But then I got to do times the derivative of the inside, which is, what's the derivative of what I plugged in? 2x. What's the derivative of that? Times 2. It's the chain rule version of the fundamental theorem of calculus.
Why did you take the derivative? You just cancel out
It's part of the rule that when you do the derivative, all right, the derivative and the integral cancel. You get the function. That's when you have just numbers and x's on the bounds. However, if you've got a function, something other than x, if you have a function on the bounds, then you're going to use what we call the chain rule. Derivative of the outside, inside stays the same, times the derivative of the inside. That's that times derivative of the inside. It's the chain rule version of the fundamental theorem of calculus. And the 2's coming from the times the derivative of what you plugged on the inside. The derivative of the integral cancels, you just get that part with 2x plugged in, but then times derivative of the inside. But what's my question though? My question is, one more hoop to jump through. What's f prime of 1? This is the square root of 5 plus 2 times 1 quantity squared times 2. Well, 2 times 1 is 2, squared is 4. 4 plus 5 is 9. I'll write it like this for your benefit. That's the square root of 9 times 2, just because I don't want you to show you that I'm just doing it one step at a time. What's the square root of 9? 3 times 2? Yeah, answer 6. Let's see.
You mentioned that since the 2x is on the top,
Yeah.
you would actually have to plug in 2x in the problem.
Well, of course, and whether it's on top or bottom, it's a variable when taking derivative with respect to x. The variable is on top. However, if I happen to put the variable on the bottom, from the first fundamental theorem of calculus, it's top minus bottom. Since the variable's on the bottom, it'll have a minus you plugging all this stuff in. Look at the next question. Let f of x be equal to x divided by x squared plus 1. Find the area under the curve of f above the x-axis for the interval between 0 and 2. Again, what a surprise. Area under the curve. What are you going to do when you have area under the curve? You're going to integrate x over x squared plus 1 dx. And my bounds are between 0 and 2. This is going to give you area under this function back to the x-axis between 0 and 2. Well, you still have to integrate this thing. Before I plug in bounds and stuff, I got to integrate it. What technique of integration would I use? U substitution. What would you let u equal to? Denominator, x squared plus 1. What's du? Derivative is 2x dx. And you move the constant to the side. 1/2 of du equals x dx. And notice that there's an x dx in the problem. So when I convert this over, this is an integral. This is a division problem. This was u on the bottom. And the x dx gets replaced with 1/2 du. The half's a constant. I always put that up front, the u in the back. And I put a 1 in the numerator for placement. U substitution. Classic technique of integration. Now, what's the integral of 1/2 of, what's 1/2 the integral of 1 over u to u? Pure memorization of formula. That's 1/2. What's the integral of 1 over u? Natural log, crucially absolute value of u. Back substitution, because we got bounds. 1/2 the natural log absolute value of x squared plus 1, evaluated from 0 to 2. Applying the fundamental theorem of calculus, part 1, you take 1/2 the natural log of 2 squared plus 1, minus 1/2 the natural log of 0 squared plus 1. The famous plug-in top minus plug-in bottom to evaluate. Let's do some math. 2 squared is 4, plus 1 is 5. This is 1/2 the natural log of 5. Minus 1/2 the natural log of 0 squared is 0 plus 1 is 1. However, again, no calculator on this section. You still have to tell me things you're supposed to know. What's natural log of 1? 0. Things we know from pre-calculus, college algebra stuff there. That's 0. So we left with 1/2 the natural log of 5, and 1/2 the natural log of 5 is answer B. All right, question for you. I actually did, and look at the multiple choice. There were 15 questions on this. They usually range between 12 and 17 questions. I've seen them as much as 17 questions on the multiple choice on the no calculator, and as few as 12. 13 to 15 is usually about average for this thing. How long did it take me to do this? Now, I got started a little late because we passed out some papers and Liz had to make her announcement. Then Desiree and Bella came inside here. That's awesome. But so I got started about 15 minutes late. How long did it take me to do this? About 30, 35 minutes or so. And then I gave you guys explanation. So remember this. Part 1. For most people, they will be finished within 30 to 40 minutes of part 1. How long do you have to finish up part 1? 1 hour. You have 1 hour to do it. It is a timed event. You have to do it within an hour. But most folks are done between 30 and 40 minutes, honestly. That's on average. But you got some extra time. You can go back and look it over, make sure. But once you're done with part 1, I still got 20 minutes before I'm allowed to use the calculator. That's all right. Just don't sit there and twiddle your fingers and stuff. This is a large exam. It's going to take you a good 3 hours to do this thing. About 2.5 to 3 hours. Okay? Because there's going to be some more interesting parts of this thing. But you've got plenty of time is my point. But Don't hesitate and wait. We're now part 2, but I still got 20 minutes before a calculator. Don't start. You go ahead and start part 2. I don't need a calculator for most of this stuff. Watch. We can do a lot of this stuff without a calculator. And if it does require a calculator, then I will just go on to the next problem, and when I'm allowed to use my calculator, I'll go back and finish those problems up. So let's take a look at this guy. Calculator's allowed. But remember, nobody's allowed to use a calculator until you're given the official word by your professor that everybody's turned in part 1 and you can now get your calculator. Here we go. An object at position x, measured in meters, on the x-axis is subject to a force of sine x, newtons. How much work in joules is done in moving an object from x equals 0 to x equals pi halves? I don't need a calculator for this. I just got to remember, what was the formula for work? Work was equal to the integral of force dx from A to B. This, again, while you have that little side sheet of paper when you're studying, write down all the basic formulas. You've got those spring formulas, those interesting pumping problem formulas. Write down the formulas you need for that kind of stuff. But this one's your classic work problem for springs. So, work is equal to the integral. What was the force function? Force was equal to what? Sine of x. And my object's moving from 0 to pi halves, so that would be the integral from 0 to pi halves of the sine of x dx. Honestly, this problem should have been put on the no calculator section. What I got to do to this thing? Integrate. What's the integral of sine x? Negative cosine of x, evaluated from 0 to pi halves. Fundamental theorem of calculus, plug in top minus plug in bottom. The cosine of pi halves, negative cosine of pi halves, minus the negative cosine of 0. This is going to give you negative the cosine of pi halves. A minus makes it a plus the cosine of 0. Now, what's the cosine of pi halves? You don't need a calculator for that. You're supposed to have that stuff memorized. What's cosine of pi halves? 90 degrees is 0. What's the cosine of 0? 1. Now, what is 0 plus 1? 1. The answer is 1, and this was a metric problem, so distance in meters, forces in newtons, the integral, when you integrate it, you get the newton meter, also known as the joule. So the answer is B. Didn't need a calculator for any of that mess. Number 2. Which of the following is the best approximation to the length of the curve? Again, while you study old final exams. How do they word this? In my class, we kept talking about what? Arc length. But what's the definition of arc length? The length of the curve. Okay, so we're supposed to find arc length. There are 3 formulas for arc length you're supposed to have memorized. The basic one was arc length was equal to the integral from A to B of the square root of 1 plus the derivative of your function squared dx. You got the arc length is equal to the integral from A to B of 1 plus the derivative squared dx. You got the integral from C to D of the square root of 1 plus the derivative with respect to y squared dy, in case you want to do y1. And you had the parametric form, the integral of the square root of dx over dt squared plus dy over dt squared dt. So there's 3 forms for arc length. But this one was nice. But you got to work it though. The function is y equals the natural log of x. You need the derivative. What is the derivative of the natural log of x? 1 over x. And I'm going to plug it right in there. So this would be, arc length would be the integral of the square root of 1 plus 1 over x squared dx from what are my bounds on this thing? What are my a and b? A is 1, b is 3. From 1 to 3. Does that make sense? You can clean this up if you wanted to. Arc length is equal to the integral from 1 to 3 of the square root of 1 plus 1 over x squared dx. However, what technique of integration am I going to use on this one? Calculator. Why? It's not. Look at the answers. What are the answers they want me to find? 2.3, 2.5, 2.6, 1.3, and 4.2. I got bounds on this thing. I'm doing arc length. I mean, I'm going to sit there. This thing's going to be nasty. I'm going to have to get a common denominator, factor some stuff out, and see if I can get this thing working for you. And even then, I don't think I can get this thing to work out anything decent except a table in the back of the book. But what really clues me in that I'm actually supposed to use the calculator on this guy is this. It's the answers. They're all in decimals. I'm going to have to convert it eventually to a decimal version anyway. So here I go. So I'm using my Texas Instrument TI-84 on this guy. By this time I have a calculator. If I don't have a calculator at this point, I would have left it and gone on to other questions and then come back and finish this problem up, because at this point it's real easy. I'm integrating from 1 to 3 of the square root of 1 plus 1 divided by x squared with respect to x. And double check it, make sure it looks exactly like what you're trying to calculate. And I got 2.301987535. So in terms of my guessing of answers here, what do you think it is? 2.3. I think the answer is A. Does that make sense? Don't lose you guys anywhere. So, speaking of that, and I was told to make this announcement to you guys. When you come to the exam, you are supposed to have 3 things. A pencil, or maybe multiple pencils, but you have to have a pencil. All math is done in pencil. Don't do any of this math in pen. We just will hurt you and take extra points off for looking at that crap. It's got to be in pencil, and you got all this OpScan stuff anyway. Pencil, pencil, pencil. Number 2, lead pencil. The second thing you got to have is a calculator. You don't get to borrow calculators during the exam. You should never borrow a calculator on any exam to this date. That's called cheating. And on the final exam, that's a sure way of sending you to the police department. No cheating, no using of other people's calculators. You have to use your own. And speaking of that, when you come with your calculator, just to double check with you guys, make sure you got your Riemann Sum Program at the ready, just in case they throw one of those suckers at you, that you can double check your answer. Things like that. And the last thing you got to have for the final exam is your student ID card. That's a university requirement that when you come, you will sit at your desk and you're supposed to, first thing you do is put your student ID card out on the corner of the desk, because not only will I be monitoring you guys, my graders will be monitoring you guys, as well as faculty members throughout the math department and other departments will be looking in and monitoring you guys and want to make sure if there's a problem, they can find out who you are and by your ID and stuff. All right? Yeah.
Is that going to be under units or unit? It's just like, what's
Officially, if I had units on this, would be an arc length, there would be units, meters, feet, something like that. All right. Number 3. Find the Riemann sum for f over the interval between 0 and pi halves using 2 subintervals of equal width and taking sample points to be the left endpoints of the subintervals. Remind yourself, you know they're going to throw some Riemann sum on you. Left, right, trapezoid, midpoint, and Simpson's rule. Make sure you got your formulas memorized. Don't walk on this in this exam without you studying and making sure you got all the formulas memorized. So you should write down the formulas for the left, the right, the midpoint, the trapezoidal rule formula, and the Simpson's rule formula. All right, so here we go. This one's easy because it's a left Riemann sum, because they want me to use left endpoints. But here's the deal. During Riemann sum, it's the sum of f of x, I, times delta x, where delta x is equal to b minus a divided by n. My endpoints are a is 0 and b is pi halves. So my delta x would be pi halves minus 0 divided by 2, because I'm supposed to have, 2 subintervals here? So n equals 2. What's pi halves divided by 2? Pi fourths. Divided by 2 is, you invert multiply, that's multiplied by a half. Pi halves times a half is pi fourths. So, keep on going here. So if I'm going to sit there and look at this guy, I like to draw it out. This is always helpful for me. I'm supposed to do Riemann sums between 0 and pi halves with 2 subintervals. So my delta x, my change from 0 to my first point, that's going to be pi fourths. And then add another pi fourths plus a delta x of pi fourths gives me my pi halves. Your delta x is the width of each interval. It's pi fourths here. Delta x here is another pi fourths. Pi fourths plus pi fourths is pi halves. So these are my endpoints. What kind of Riemann sum do they want me to do? They wanted me to do a what? Left. So at each subinterval, pick the point on the left, because we said left Riemann sum. For this subinterval, the point is on the left. So remember, your Riemann sum left formula is the sum of f of xi times delta x. So it's f of your left endpoint of 0 times delta x of pi fourths, plus f of your next left endpoint, which is pi fourths, times delta x of pi fourths. What is the function that they gave you on this problem? It was the sine of x. They gave that to you actually in the problem right here. Let f of x equal sine of x. So let's see what you guys remember. This is the sine of 0 times pi fourths plus the sine of pi fourths times pi fourths. Let's see how good you guys are. What's the sine of 0? 0. It's embarrassing. Times pi fourths plus what's the sine of pi fourths? You're supposed to have that one memorized too. Square root of 2 over 2 times pi fourths. 0 times anybody is 0, so the answer is going to be the square root of 2 times pi divided by 2 times 4 is 8. There's the answer, and I could have put this on the no calculator section, but I would have made it that answer. But look at your answers. They're all decimals. Okay, great. So I'm going to go back to the calculator here. I'm going to type in the square root of 2 times pi on the outside there divided by 8. I got 0.5553 something or other. 0.5553. Which answer is it going to be? Oh, I'm off the page there. 0.5553 rounds up to what? 0.56, which has got to be answer E. All right? But, just want to check my calculator. You know what kind of problem this was? It was a Riemann Sum Problem. And you know I have a program, and I believe every professor that's in here, or at least their classes are in here, actually gave you guys the Riemann Sum Program. This is a problem that you could have legitimately checked your answers on. I wanted to go through it with you because I am trying to review you guys for the final exam. But if I wanted to get that quick answer out of it, I go to y equals, I clear out the old graph there and hit the sine of x. That's my function. I go to second quit. I go to program. I scroll down to my mini programs and go to Riemann Sum. What is A on this particular problem? What was my left endpoint? 0. What was B? Pi over 2. What mode should your calculator always be in a calculus class? Radians. If you're in degrees, you will screw up several questions on this exam. Don't make sure you're in radian mode. All right. What is N? What was the number of partitions? 2. And it gives me all my answers there. And which one did we want to find? The left Riemann sum. There it is, 0.55. If they switch it up to the right Riemann sum, I would have gotten 1.34. So there's the person who didn't pay attention to that. If it was trapezoid, 0.948. Midpoint, 1.03. And the Simpsons rule is close to 1.001 something. Just want to remind you that. Yes, sir.
When would you have to use like degrees? Because sometimes I'll have to switch back and forth.
All right. The question is, when do I use degrees? In calculus and in science-based mathematics, never. In physics is where you're going to use degrees. When they want to know the pitch of the roof, when you're actually constructing something or other, I don't tell the people that are actually, repairing my roof that I got a pitch of pi 6 radians. He'd look at me like I'm nuts. He has a 30-degree pitch or a rise, a 4-3 rise run type thing here. So you use degrees when you're actually constructing stuff, and that's classic physics when you're trying to communicate. So you see that a lot also in your engineering classes. But when it comes to math classes, you got to do the science-based stuff, which is always radians.
Would you want to do that? Like you want to leave it in degrees whenever you get to work, or Hooke's law and stuff like that?
No, always radians. Always radians. Even the work problems and stuff, when we do problems we're doing scientifically to measure stuff, always radians. The only time I switch it to degrees, if they actually mention the word degrees in a problem.
Okay.
All right, here we go again. You know you're going to get partial fractions on this thing, so enjoy. Man, this was awfully nice of them to do this. You're supposed to find the partial fraction expansion of x plus 3 over x minus 1 times x minus 2. It is rare that they do this for you. What do? They factored it for you because they were worried about you. All right, but here it is. X plus 3 divided by x minus 1 times x minus 2. You know you're going to bust that up to a over x minus 1 plus b over x minus 2. And so you're doing your partial fraction stuff, and you're supposed to find b, and that's really why they did this, because they have to denote which coefficient is going to be b. But how do I do partial fractions? Well, since they went ahead and factored it, I'm going to multiply the entire equation by my common denominator, x minus 1 times x minus 2. When I do that, the complete denominator factors, I'm left with x plus 3 equals a times x minus 1 cancels, leaves me with x minus 2, plus b, the x minus 2's cancel, you're left with x minus 1. Okay? Now, we're doing what I call the Annihilator Method. Depending on who your professor is, they may have done the system of equation method or whatever, and that's fine. You're going to see this a lot, especially in differential equations class. But I like the Annihilator Method, because once I clear denominators, this thing's going to work for all x's. So I'm going to pick a couple x's. I like the x's of 1, and I like the x's of 2. Okay? So the reality is all I really need is 2, because I'm trying to solve for b, but I'm going to do both of them because you need to practice. So I'm going to plug in x as 1. 1 plus 3 is 4, equals a times 1 minus 2, plus b times 1 minus 1, which is 0. Eliminates the b term. So 4 is equal to 1 minus 2 is negative 1, negative a. Divided by negative 1, I get a to be negative 4. However, they didn't want me to solve for a, I want to solve for b. So to get the b, I'm going to plug in 2. 2 plus 3 is 5, equals a times 2 minus 2, which is 0, plus b times 2 minus 1, which is 1. So what's b equal to? 5. And that's really the answer that they wanted. The answer is E5. But look at your next problem here. It says this. The speed of a runner increased steadily during the first 2 seconds of a race. Time t is measured in seconds, and b is measured in feet per second. The runner's speed at half-second intervals is given by the table. So 0 to 0.5 to 1 to 1.5 to 2. He's going from 0 feet per second to 6 feet per second, 13 feet per second, 21 feet per second. After 2 seconds, he's already up to 30 feet per second for velocity. Based on the information given, which of the following is the best upper estimate for the distance traveled during these 2 seconds? Remember this. This is classic web-worky type stuff here, but they're giving you a chart, so there's no function. You got the velocity, and they want the, quote, distance traveled. To get distance traveled, I have to integrate velocity. The problem is I don't have a function to integrate. They gave me a chart. To be able to analyze charts, you got to do Riemann sums. And to get the best over and under estimates for Riemann sums, what are you going to use? Left and right endpoints. That's what you're supposed to use. You're not supposed to use midpoints or anything like that. You're supposed to get the best estimate, the best upper and lower estimates. You're supposed to use left and right Riemann sums. So here we go. If I'm going to do this problem, I'm going to do a lower Riemann sum, which is a left Riemann sum, and an upper Riemann sum, which is what they call a right Riemann sum. This is the sum of f of xi times delta x. This is going to be the sum of f of xi times delta x, but you got to use the different points. Left point versus right point. These are my partitions. From 0 to 0.5. From 0.5 to 1. From 1 to 1.5. And 1.5 to 2. My delta x happens to be, my n is 4. What's my delta x equal to? Or in this case, delta t. What's my delta t equal to? 0.5. Every partition is being separated by a half of a second. Does that make sense? So my delta t is 0.5. So to do the left Riemann sum, remember it's f, the sum of f of xi times delta x. F is the value. I'm using the left Riemann sum. The left point from the first interval is 0. Times delta x, or in this case delta t, is 0.5. Plus, for the next partition, is between 0.5 and 1. The point on the left is 6 times 0.5. Plus, the next partition is between 13 and 21. The point on the left is 13 times 0.5. And the last partition is between 21 and 1.5 and 2, which is between 1 and 30. I use the point on the left, which is 21 times 0.5. Notice My partition broke up into 1, 2, 3, 4 intervals. 1, 2, 3 things. 1, 2, 3, 4 things I'm summing up here. All right. So this is equal to, well, 0 times 0.5, that's easy. 6 times 0.5, that's like 3. Plus 13 times 0.5, plus 21 times 0.5. I end up getting 20. That's either the lower or upper estimate. I believe this is going to be the lower one because I'm using the smaller numbers here. But I'm just trying to show you, I'm going to do both of them, and then if they want the upper estimate, I give them the big number. If they want the lower estimate, I give them the small number. So for the right Riemann sum, same partitions, but I'm now going to use the point on the right. Between 0 and 6, the point on the right is 6. That'll be 6 times 0.5. Plus, between 6 and 13, the point on the right is going to be 13 times 0.5. Between 13 and 21, the point on the right is going to be 21 times 0.5. Plus, between 21 and 30, the point on the right is 30 times 0.5. So adding this stuff up, I get double check me, but I got 35. And so this is a distance. So what is the, quote, upper estimate? What's the upper is the bigger estimate. What is my bigger estimate? 35 what? This is your integrating velocity, which gives you distance. Distance is measured in feet. The answer is C. Does that make sense? So anytime you're supposed to give an estimate for an upper estimate and a lower estimate, and they give you a chart, they're asking for left and right Riemann sum. Which one's going to be the upper? Which one's going to be the lower? Honestly, I don't know. I have to actually do both left and right Riemann sums. The bigger number is the upper estimate. The smaller number is the lower estimate. That's how you get your answers. Question? Yeah.
What would an equation where the left would be bigger look like?
Oh, where you'll notice in this problem, if you look at your data, the graph, if you graph these points out, they're getting bigger. As time goes on, he's speeding up. He's getting bigger. So where the left would be bigger if something that would be going down, like getting slower or something like that, the graph would go the other way. All right, number 6. A particle is moving along the x-axis at a rate of t cubed centimeters per second. And what is the average velocity of a particle between 0 and 2 seconds? All right. This one right here threw a lot of people off because they didn't know what to do. And that was a shame, because I want to remind you of another formula you're supposed to have memorized. And that formula is this. It is called the average value. That's the formula for in Calculus 2 for average value is the integral, 1 over b minus a times the integral from a to b of f of x dx. This is your average value formula. It is going to give you the average value of f, of the function. What function did they give me? They gave me a velocity function. Look at it. It's moving along at a rate of t cubed, what? Centimeters per second. Look at those units. Centimeters per second. That is velocity. Does that make sense? All right. So, they want to know what is the average velocity. So they wanted the average value of the velocity function. So this average velocity, I'm going to use my average value function for between 0 and 2. A is 0, B is 2. So this would be 1 over 2 minus 0 times the integral from 0 to 2 of your function, which is t cubed dt. But you can see how this wording threw off a lot of people once you figure out, oh, all they wanted was the average value. I wouldn't have picked that up from that problem. That's why you're studying this stuff. So you guys can see what they're looking for in these kind of problems. So now let's clean this sucker up. This is equal to 1/2 times the integral from 0 to 2 of t cubed dt. This is 1/2 times integral of t cubed is t to the 4th over 4, evaluated from 0 to 2. Cleaning it up, this will be 2 times 4 is 8. So this is 1/8 t to the 4th, evaluated from 0 to 2. This should have been on the no calculator section, by the way, because I don't need a calculator for this. This is 1/8 times 2 to the 4th minus 1/8 times 0 to the 4th. Well, that's 0. What's 2 to the 4th? 2 times 2 times 2 times 2. 16. 16 divided by 8 is what? 2, and don't forget your unit, centimeters per second, because it's an average velocity. So I get 2. The answer is D. Does that make sense? Did I lose you guys anywhere? How far does a particle travel in part number 6? Well, that's great. Got to go back and pull part number 6 again. But so we had the velocity equation, which was equal to t cubed. That's really what you're pulling it off here. And your interval, Dave gave it to you again, is between 0 and 2. Now, if you wanted to know distance, here we go. How do I calculate distance? What am I going to do? I'm going to integrate velocity. So my distance, because it's t cubed, and if you look on your graph, it's all going to be positive distance between 0 and 2, because it looks like that on the graph. It's all positive there. So to figure out the distance between 0 and 2, all I have to do is integrate from 0 to 2 of t cubed dt. Okay, you integrate your velocity. So distance is integral officially the absolute value of velocity, just reminding you of some formulas you're supposed to know, dt. All right? So 2 words there. All right, so what I'm trying to get you to do here is this. There's 2 concepts. The concept of total distance versus the concept of displacement. You need to know both formulas. So, what is the formula for total distance? The total distance, you're going to integrate from A to B the absolute value of your velocity. So you want to separate the negative velocity going in the other direction from the positive velocity. Going from left versus going to right, dt. That tells you total distance. To actually get displacement, that you want your negative to cancel out with positive. So if I go 5 feet to the right and 3 feet to the left, my displacement, where am I at relative to where I started from, would have been 2 feet. 5 minus 3. You want the negative to cancel with the positive. And to get that, you just integrate without absolute values, just the velocity dt. The difference between the 2 formulas. This total distance versus displacement. So, here we go. This is equal to, what is the integral of t cubed? Don't hurt yourself. T to the 4th over 4, evaluated from 0 to 2. This would be equal to 2 to the 4th over 4 minus 0 to the 4th over 4. That goes away. What's 2 to the 4th? It's 2, 2, 2, 2. 16 divided by 4 is 4. Minus 0 is 4. 4 what? This thing was measured in centimeters. So the answer would have been 4 centimeters. The answer is A. Don't lose you anywhere. All right, keep going. All right. Look at the next problem. Now, I want you to understand there's 2 different ways of doing this problem. You can do it the lazy man's way, which is okay on the multiple choice. But then there's the free response, show your work and be detailed about your work way. That's your free response way. And because I'm trying to get you guys to review on the final exam, I'm going to do it the way that if they put this problem on a free response, I expect you guys to do this. What is the integral from 2 to infinity of 1 over x squared? This is an improper integral. Okay? Fact of the matter is, to show your work, you can to do a proper integral, you're going to have to turn this into, pick your favorite letter. I'm going to take the limit as a approaches infinity of the integral from 2 to a of, clean up your function, x to the negative 2 dx. This turns improper integral into proper by doing the limit stuff. You remember, you can't divide by 0, and you can't have bounds of infinity on this stuff. So you have to worry about bounds where you divide by 0, and you got to worry about bounds of infinity or negative infinity. Those are improperness. So, first thing you got to do is got to integrate the darn thing. It's called calculus 2. So what's the integral of x to the negative 2? Add 1 over add 1. That's x to the negative 1 over negative 1. Evaluated from 2 to a. All right, clean it up. This is equal to the limit as a approaches infinity of negative 1 over x evaluated from 2 to a. All I did was clean up my function. So far, so good? Now, according to the fundamental theorem of calculus, plug in top minus plug in bottom, showing my work, I write word limit all the way up to the point where I actually plug in infinity. This will be the limit as a approaches infinity of negative 1 over a minus negative 1 over 2. Cleaning it up for your benefit, this is the limit as a approaches infinity of negative 1 over a minus a minus is a plus 1/2. Now, plug in infinity. This is negative 1 over infinity. Once I plug in infinity, I don't write limit anymore. Plus 1/2. But what is 1 over infinity? When the infinity is on the bottom, what's this thing go to? 0. So this goes to 0 plus 1/2 is 1/2. Being an improper integral, we would describe the answer as convergent to. Improper integrals always have this convergent to or divergent as a response to the integral. So the answer is convergent to 1/2. That's how I would do it if I was actually doing the problem on the free response part. Or if it was on the multiple choice part without a calculator. Maybe I wouldn't do so much in terms of being detailed about the limit. Focus on the limit, how I wrote limit, 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 limit on each part. That's what they want in the free response, showing your understanding of how to write up, not just getting the answer, but how to write up the answer. But this is multiple choice, and it's on the calculator section. Honestly, I think 99% of the people I saw actually doing this problem did this. All right, math number 9. Let's integrate this thing. 2 to infinity. If you have a T89, there's an infinity button. If you don't have a T89, I got a T84. What's infinity? About 100. All right, and then he wants a big number. 1 divided by x squared dx. Yeah, I'll show you how to cheat. What do I get? It's thinking about it. I got 0.49. Okay, fine. I only put up to 100 there. Is that 0? Is that 1? Is that a half? Or is that negative 1? Yeah, I can nail that one. So, it's multiple choice. You don't have to be as detailed on your work. And only a moron wouldn't use a calculator on a problem like this to double check themselves. That's why we give you guys the calculator. Personally, this problem probably deserved to be on the no calculator section. Okay? Take a look at the next one. But if this problem was on the free response part, this is the way you should write it up. Because they're not, on the free response, they're not just grading the answer, they're grading the process of how you got to the answer. That's why I'm showing you every detail so you don't miss anything. All right. Which of the following is the interval of convergence of this power series sum as n goes from 1 to infinity of x plus 1 to the n over n? Now, when you hear the magic words, interval of convergence of a power series, and our last test, which was what? For some of you guys Tuesday, for my guys it was on Monday, what you thinking? You know it, ratio test. So we're going to do the ratio test on this sucker. So I'm going to take the limit as n approaches infinity, the absolute value of an plus 1 over an. This will be the limit, and again I'm showing all details of my work just in case this problem shows up on the free response, which has a very good chance of doing, by the way. So this will be the limit as n approaches infinity of the absolute value of x plus 1 to the n plus 1 over n plus 1 divided by an, which is x plus 1 to the n over n. Now, when I'm doing a fraction divided by a fraction, I'm going to invert and multiply, and to save myself lots of time and space, I'm going to invert and multiply and go ahead and collect like terms. What I mean by that is this. This is the top, x plus 1 to the n plus 1. The n plus 1 is on the bottom, so I'm going to stick him on the bottom. When I flip it up, the n shows up on top, and I'm putting my n's with my n plus 1s because we're going to group together like terms. And when I flip it up, the x plus 1 to the n is going to stay on the bottom, and I'm going to put it over there with the other x plus 1 to the n plus 1. Just saves myself lots of time. Now, ratio test. The ratio test is really great for powers of n and or factorials. That's when you really want to use this thing, because it really kills off these powers of n. What is x plus 1 to the n plus 1? That's the same thing as x plus 1 times x plus 1 to the n. And you'll notice that the x plus 1s to the n's cancel, leaving you with a single x plus 1 on top. Now, I've got to do this other part here, so I'm going to rewrite this. This will be the limit as n approaches infinity of the absolute value of x plus 1 times n over n plus 1. Now you're going to take the limit as n approaches infinity. Here is my ratio. It is n over n plus 1. If I plug in the limit as n approaches infinity, I'm going to get infinity over infinity. When I get infinity over infinity, officially I'm going to do L'Hopital's rule, or you can just look at the derivative of the top, derivative of the bottom. What are you going to get? That's going to give you 1. Derivative of n is 1. Derivative of n plus 1 is 1. It's 1 over 1. Or since it's 1 over n over n plus 1, it reduces down to 1 anyway. All right, so what are you left with? Absolute value of x plus 1. This is the ratio test. We're trying to put a gun to its head and decide when it's going to converge. When does the ratio test converge? Got to be less than 1. So you set it strictly less than 1, and then you do the absolute value inequality stuff. Remember, absolute value of x is less than b implies negative b is less than x, which is less than b. But this implies that negative 1 is less than x plus 1, which is less than 1. All right? Solving for x, subtract 1 from all sides, and you end up getting negative 2 is less than x, which is less than 0. Are you done with the ratio test? Well, I'm kind of done with the ratio test part. However, I'm not done with the problem, because what do you have to do to the ratio test when you're trying to figure out the interval of convergence? You've got to check those endpoints. So, what are my endpoints? My endpoints are x equals negative 2, and the other endpoint is going to be x is equal to 0. And I'll put that one over here. X is equal to 0. EPs, endpoints. All right? So let's first focus on the endpoint negative 2. You plug it back into the original series. This would be the sum as n goes from 1 to infinity of negative 2 plus 1 to the n over n. This is the sum when you clean it up. What is negative 2 plus 1? Negative 1 to the n over n. Stop, pause, and look at this series. What is the sum as n goes from 1 to infinity of negative 1 to the n over n? What kind of series? Alternating series. What test should you use being an alternating series? Things we have memorized, you should use the alternating series test. The Bn, the part without the alternation, is 1 over n. The alternating series, you have to test it out. By the first part, you've got to make sure the terms go down. N is 1, n is 2, n is 3. That's 1, 1/2, 1/3. The terms go down. And most important, number 2, you take the limit as n approaches infinity of 1 over n. And what's 1 over infinity equal to? 0. The terms go down. The limit goes to 0. What's it going to do by the alternating series test? Converges by alternating series test. So in other words, we want that point of negative 2. So I'm going to put equal to on that part, because I want to include the negative 2 point, because it converges when I plug in negative 2. Now check your other endpoint. The other endpoint, I plugged over here on the other side, x is equal to 0. When I plug it in, I get the sum as n goes from 1 to infinity of 0 plus 1 to the n over n. What's 0 plus 1? 1 to the n over n as n goes from 1 to infinity. But what is 1 to any power? 1. 1 to the n power. It's not negative. It's positive. 1 squared, 1 cubed, 1 to the fourth is all 1. This turns into the sum as n goes from 1 to infinity of 1 over n. That's a real special series. That sucker's got a name. What's its name? Harmonic Series. And what does the Harmonic Series do? Diverges, which means I do not want that point of endpoint in my interval of convergence. So, here is my answer. It is between negative 2 and 0, including negative 2. Its interval notation, that would be bracket negative 2 to 0, which is answer, which one? Bracket negative 2 to 0 is answer Z. Does that make sense? Look at this particular exam. It should worry you. Why should it worry you? Hey, look at all the series stuff they put on it. This is awesome. But at least this was the last material you covered, which should be the most recent stuff in your mind. But remember, 60% of this exam is going to be about integration here. All right. Consider the series, the sum as n goes from 1 to infinity of 1 over n cubed. Stop for a second. Look at that thing. Tell me its name. P series. What's P equal to? What does it do? All right, we're on our right track then. Which of the following tests results in a successful determination of the convergence or divergence of this series? Well, it's a P series. P equals 3. Well, that's awesome. It's not even one of my answers. But what's the answer? Converges. Well, here we go. Should you use the alternating series test on this? Why? It's not alternating, so this is stupid. Keep going. All right. Should you use the divergence test on this thing? Why not? Well, the limit as n approaches infinity of the sequence part does go to 0. If you get any other number than 0, if the sequence part doesn't go to 0, the series automatically diverges. But the limit as n approaches infinity of the sequence part is actually going to 0. So that would be stupid to use the divergence test. Would you ever use the ratio test on this thing? The nuclear bomb of test? No. Why not? There's no powers of n and or factorials. That's the only time you want to use the ratio test on a series. Powers of n or factorials. And we don't have that, so that's stupid. Would you use integral test? Integral test. Why would you use integral? Or why could you use the integral test? Because you can actually integrate it. This is the integral from 1 to infinity of 1 over x cubed dx. You can actually integrate that guy, which would be the integral from 1 to infinity of x negative 3 dx. You actually don't have to integrate it, but I could have. So this is actually the answer D. As I mentioned to you guys before, there's more than one test that can give you the right answer, but there's only one right answer. That series converges. It is a p-series, but I could also use the integral test to prove it. The last one would you actually compare to the terms of the sum as n goes from 1 to infinity of 1 over n? Why not? What kind of series is this guy? Harmonic series, and I would only compare it to the harmonic series if I have something that reduces down to something looking like 1 over n. We got 1 over n cubed, so that would be also stupid. So just want to know that there's only one real answer up here. Personally, they should have put, it's a p-series. Be done with it. All right, but they didn't put that. They put integral test instead. All right, here's another one. What is the coefficient of x cubed in the Maclaurin series expansion? I warned you guys, and I put this even on my test for my guys. You had to have your series, special Maclaurin series memorized. Why? Because they're so easy to manipulate. And you will be seeing these type of series, especially for your engineers, mechanical, electrical engineering, and especially these type of series in your future. All right? So, first things first. This is e to the 2x. If I want a Maclaurin series for e to the 2x, what Maclaurin series do I have memorized that I can manipulate to get that? E to the x. What is the Maclaurin series for e to the x? 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot dot dot. Things we have memorized. And yes, you need to have it memorized. Don't get me wrong, I could take 20 minutes and go derive this thing with my Taylor series, Maclaurin series formula I have memorized. But these guys are so special. If you know them, man, it saves you like 10 minutes of work right there. So, but that's not the guy we want. Who do we want? E to the 2x. So what do? Why are a series so wonderful to work with? They're easy to manipulate. So what do I want to do? I want to replace x's with what? 2x, and I get the series for that guy. This will be 1 plus 2x over 1 factorial plus 2x quantity squared over 2 factorial plus 2x quantity cubed over 3 factorial plus 2x to the 4th over 4 factorial plus dot dot dot. What was the question on this dude? What's the coefficient of x cubed? In other words, this is the term I want you to clean up. So just this term. I've got to cube it now. 2 cubed is what? 2 times 2 times 2. 8x cubed over 3 factorial. Clean it up some more. What's 3 factorial? So that'll be 8/6 cubed. Reduce your fraction. What's 8/6 also known as? 4/3 x cubed. What's the coefficient? 4/3. Clearly the answer is D. Was this a hard problem? But I saw a lot of students screw this problem up. You know why? They didn't know where to start. They didn't have the Maclaurin series for anything. They never heard of the Maclaurin series. They haven't been to class in 2 weeks. So they're screwed. But you guys know this stuff. Memorize. What series do you need to know for this exam to make it easier for you to get these quick answers? Maclaurin series for e to the x, sine of x, cosine of x, and arctangent of x. Those are your classic ones. I think there's a 1 over 1 minus x as well. Make sure that's one of the first ones on that sheet that I gave you guys. Memorize those. Whoa, another series question. Here we go. Consider the series. Sum as n goes from 1 to infinity of -1 to the n divided by the square root of n, which is the formula -1 plus 1 over square root of 2 minus 1 over square root of 3, yada, yada, yada. Which of the series is true? First off, what's the deal here? First is this thing. First off is this. What kind of series is it? What kind of series? It's not a P series. Why? That -1 to the n commands it more so than the fact that you got a n to the 1/2 here. That -1 to the n makes it what kind of series? Alternating series. So you need to use the alternating series test on this thing. Is the series going to diverge or converge? Figure that part out first. This is an alternating series. So I'm going to use the alternating series test on it. If I use the alternating series test, the Bn part is going to be the 1 over the square root of n. So I'm going to test two things. Number one, I'm going to make sure the terms go down when I plug it in. So if I plug in 1, I get 1 over the square root of 1 is 1. When I plug in 2, I get 1 over the square root of 2. When I plug in 3, I get 1 over the square root of 3. The denominator is getting bigger, so the terms are going down. That checks. Number 2, I'm going to take the limit as n approaches infinity. And what am I going to get? Off 1 over the square root of n. I get 1 over the square root of infinity. Square root of infinity is infinity, and 1 over infinity is 0. The terms go down, the limit goes to 0. Therefore, this thing is converging by the alternating series test. So the answer is converges. So the answer is now either going to be C, D, or E. A and B answers are completely out. Does that make sense? How you analyze or attack one of these kind of problems. So let's keep going. It's got to converge. So the question is, will it converge to a negative number, a positive number, or 0? No. All you got to do is just write out the terms. They wrote them out for you. And they wrote them out. So let's grab the calculator. This is the calculator version of this thing. So let's just write out what we got so far. All right, clear it out. Let's see here. -1 plus 1 divided by the square root of 2 minus 1 divided by the square root of 3. If you think you need some more terms, write them out. What do you think the next term is going to be? Plus 1 divided by what? Square root of 4. Okay, yeah, it would also be on as 2. All right, you need some more terms? Knock yourself out. -1 divided by the square root of 5. Need some more terms? If you don't, just hit enter. I don't care what the number is. The question is it going to a negative number? Is it going to a positive number? Is it going to 0? Look at that number right there. It's going to a negative number. I wrote out several terms. I'm getting like -0.817 something or other. I can do some more terms if you want. Sure, knock yourself out. What's the next term going to be? Plus 1 divided by the square root of 6. Darn thing's still negative. Plus another one. So forth and so on. And eventually you end up getting the pattern on this thing. Because that first term was negative, it's alternating. It's always plus a little bit, minus a little bit more, plus a little bit, minus a little bit more. But that negative one in the front really told them what sign it was going towards. The answer is it's going towards a negative number. The answer is C. Does that make sense? And notice I took my time on explaining this stuff to you guys. If I didn't have to explain so much to you guys, I could have finished this exam a lot quicker. But if you'll notice this thing, it still took me less than, about 45 minutes or so to do this part. Okay? So, now, this is the part you really want to shine for your professors on. You want to show them what you know. So this is the part where you don't skip steps and you show all the details of all the things that you know, because we do grade on partial credit. So it's not just showing you the work, but it's not about getting the right answer. You literally could get the right answer on a free response question and get no credit for it. Why? Because you didn't show how you got the work. All we know is you may have looked on your neighbor's paper or something or other when no one was looking. You got to show your work. You got to know what you're doing. All right. On this particular exam, there are 5 questions. Let me tell you what goes on the day after you guys take the exam. The math department has something called the famous grading party. All us poor underpaid faculty members or professors get together and bring your free responses with us, and each professor gets 1 problem to grade. I got problem number 4 to grade, and I have to grade 1,500 problem number 4s. And I do it for 2 hours. But the reason why is consistency. Whether it's my students or somebody else's students, I'm looking for certain types of work to deviate correct number of points. So we're trying to be very consistent on grading these free response questions. So every calculus professor has to grab a particular problem and grade 2,000 of them. So let's take a look at this thing. What a surprise right from the get-go. Series. They love to throw series. You're going to guarantee at least one question on series, power series, on the free response questions. Here it is. They put it problem number 1. Here's the deal. They gave you something. Certain semesters, they'll give you the special power series. Other semesters, they'll make you memorize it. Even on the free response part, they made you memorize like e to the x and cosine of x and stuff like that. So, but this one was nice. Recall that the power series of 1 over 1 minus x is 1 plus x squared plus x cubed plus dot dot dot. And the interval of convergence is between -1 and 1. Please give the power series, find a power series expansion for 1 over 1 plus x squared. All right. So 1 over 1 plus x squared is equal to 1 over 1 minus -x squared. I'm trying to link together what they gave me to what I'm looking for. This is the reason why we love power series. They're easy to manipulate from an algebra perspective. Also, is how your calculators and your computers are programmed these days to be able to do so much math with these interesting transcendental functions that are all over the sines, cosines, tangents, e to the x's, all that stuff. It's all based upon this power series mess. Now, this is equal to, what did I do here? It looks like I'm replacing x with what? And I'll put this for your benefit. Replace x with what? -x squared. So this will be 1 plus -x squared plus -x squared squared plus -x squared cubed plus -x squared to the 4th plus dot dot dot. But you want to clean this stuff up. Don't leave it like this. They'll take off a point for not cleaning stuff up. What is this going to turn into? So this 1 over 1 plus x squared from a power series perspective is this. It is 1 minus x squared. Negative squared is positive plus power to a power multiply, x to the 4th. Negative cubed is negative, x squared cubed, power to a power multiply. That'll be negative x to the 6th. Negative to the 4th is back to positive again. X squared to the 4th is x to the 8th. Power to a power you multiply plus dot dot dot. This is what they're looking for. And don't forget this. And what's my interval of convergence? And -1 is less than x, which is less than 1. Reason why? All I'm doing is replacing x with -x squared. So the absolute value of negative x squared still has to be less than 1. And absolute value of negative goes away. So absolute value of x squared is still less than 1. Take the square root of both sides, which means absolute value of x is less than 1, which means -1 is less than x, less than 1. You're going to get the exact same interval of convergence. Okay? But this is what they're looking for in terms of the power series. This is the answer that they were really looking for on this particular part of the exam. Now, look at the next question. Welcome back to calculus. Use part A to find a power series expansion for the tangent inverse of x. Well, how do I get the tangent inverse of x? What do I have to do? Look at this guy. What's the relationship between tangent inverse of x and 1 over 1 plus x squared from day 1 of this class in terms of memorizing formulas and stuff? What's the relationship? I have to integrate 1 over 1 plus x squared dx, a rule you have memorized in terms of all the thousands of integral rules you have memorized. The integral of 1 over 1 plus x squared dx is arctangent of x. So what am I going to do? I'm going to integrate 1 minus x squared plus x to the 4th minus x to the 6th plus x to the 8th plus dot 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 dx. What is the integral of 1 with respect to x? X minus what's the integral of x squared? X cubed over 3 plus integral x to the 4th is x to the 5th over 5 minus integral x to the 6th is x to the 7th over 7 plus integral x to the 8th is x to the 9 over 9. I think I got the pattern. Plus dot dot dot. But you're missing something or other. And they took off points for this. What? Plus c. Because you integrated. And you need to figure out what that c was. How do I figure out what the c is? What is a number that I can plug in for x that's in the interval between -1 and 1 that's going to kill off the tangent function? 0 is going to kill off my power series. You should know this. Since the tangent inverse of 0 equals 0, note, the tangent inverse of 0 equals 0, then the tangent inverse of 0 is equal to c plus 0 minus 0 cubed over 3 plus 0 to the 5th over 5 minus 0 to the 7th over 7 plus 0 to the 9th over 9. Who cares? All these terms go to 0, right? What does that make c equal to? And by the way, what is the tangent inverse of 0? It's 0. Things you're supposed to know from trig class. Tangent inverse of 0 is 0. You could use your calculator if you needed it. So what's c equal to? 0. So the real answer is this. The tangent inverse of x is actually x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus x to the 9th over 9 plus dot dot dot. This is what they were looking for. Alright, couple things here. And then you're going to be disappointed, but I'm going to let you know about it anyway. Did you know, question first, yes ma'am.
Since that was on the list of ones to memorize.
That's what I was about to go over, okay. Alright, since this is one of the guys on the list you're supposed to have memorized, couldn't I have just written that answer? No. Why? It's in the directions. Let's read directions again. Come on in, read with me. Use part A. Now you're screwed. To find a power series for the tangent inverse of x. If you write out the formula, they gave you a point for it. They didn't take off nothing. But you didn't actually show them that you integrated the power series to get it. Also, because this was in discussion of us graders grading this stuff, because we never actually told you to find the c thing here, if you wrote the c and didn't do all this stuff about what c was equal to 0, we still gave you credit for it. Okay? We gave you credit for this answer with the plus c, but if you just wrote out the answer without using part A, you didn't show the work. But the nice thing is this. If you had this thing memorized and you got the answer that you memorized, how happy should you be? You did do it right. Does that make sense? But it's in the directions. Okay? Now for part C. In part C, this is the part that messed up some people because they didn't know what to do. Well, some people just left it blank, But those are easy to grade. Don't get me wrong. I appreciate other people's classes doing that. All right, so the next one is this. Use part B, which is my answer right here. Even if you have plus C, it wouldn't have mattered here. To estimate the tangent inverse of 0.1 within 0.000001 of the answer. So what are you supposed to do? You're supposed to actually use the power series. Tangent inverse of 0.1 would be, I'm replacing x with 0.1. This would be 0.1 minus 0.1 cubed over 3 plus 0.1 to the 5th over 5 minus 0.1 to the 7th over 7 plus 0.1 to the 9th over 9. The question was, well, how many terms should I have taken it out to? Honestly, I think three terms. 3 terms would have worked, these 3 terms. But I'm always for overkill. Give them more. They can't take off points for giving you more stuff. So here we go. And so I just stopped off at the last thing I wrote. I didn't write out the rest of them, ... That's officially what it is. So in terms of rounding it off, here we go. This would have been 0.1 minus, parentheses, 0.1 cubed divided by 3 plus, parentheses, 0.1 raised to the 5th divided by 5 minus, parentheses, 0.1 to the 7th divided by 7 plus, parentheses, 0.1 to the 9th divided by 9. What did I get? I got the answer 0.099668 5, 2, 5. And I did cut it off to the 1, 2, 3, 4, 5th term. I just used 5 terms. But I think 3 terms would have done it. But how do I know 3 terms would have done it? Well, I got the tangent inverse button here. What mode should I be in? Of course, I'm in radian mode because that's the best mode to be in when you're doing math work. And what am I trying to do? Tangent inverse of 0.1. When I hit this button, what number should I get? It should be really darn close to this thing. At least out to the 1, 2, 3, 4, 5, 5th decimal place. Let's see what I get. I did even better than that. I got exactly what the calculator did because this is what the calculator does. Does that make sense? So I know I got the problem right. But honestly, I think all I needed was the first 3 terms. So let me show you that. If you only did the first 3 terms, 0.1 minus 0.1 cubed over 3 plus 0.15 to the 5th over 5, and just delete the rest of it. Just delete all that mess. Now all you really needed was 3 terms on this thing to do it. Well, I didn't mean to do all that. Okay, so 1, 2, 3, 4, 5. 5th one. Well, I was just having a tough time trying to get my calculator to do what I wanted to do. When I do just 3 terms, notice that I get, it does round it off, but 1, 2, 3, 4, 5, 6, I'm still good. With the 3 terms that I just used, I'm still good to the decimal places I needed. So that was the answer. All right, next one. Suppose you know this is going to be part of your test questions here. All right, consider the region R in the first quadrant beneath the graph of y equals cosine of x. Between 0 is less than x, which is less than pi halves. Suppose the region R is rotated about the x-axis. They shouldn't have to tell you this, but they're trying to force you to get this one answer for everybody. Use this method to write a definite integral that will give you the volume of the solid. You do not need to evaluate the integral. It's about they wanted you to quote-unquote set up the integral. All right. First off, you should graph the picture. Y equals cosine of x, but all I care about is between 0 and pi halves. 0 to pi halves. Cosine of 0 is what? 1. The cosine of pi halves is 0. That part of the graph looks like that. That's all they wanted. They wanted you to rotate this thing about the x-axis. Notice my function is in terms of x, and they wanted me to rotate around the x-axis. What is the logical method you would use when the function is in terms of x and you're trying to find the volume rotating around the x-axis? Dishwasher method. What is the dishwasher method? Volume equals pi times integral of big functional radius squared minus little functional radius squared dx. Functions in terms of x rotating around the x-axis from A to B. My big radius would be from the axis of rotation to the outside edge, which would be top minus bottom, cosine of x minus 0. The little radius would be 0 because when you rotate this thing around the x-axis, it's solid. So what do they want for the answer? The answer was the volume of pi times integral from 0 to pi halves of the big radius, which is the cosine of x squared dx. This was the answer they wanted. And they told you you did not have to evaluate it. Some folks did, fine, units cubed because it's volume, but this is based on the directions, this is what they wanted. Does that make sense? Now look at part B. Now suppose R is to be rotated around the y-axis. Use the method of cylindrical shells. My function is still in terms of x. And by the way, in terms of partial credit for all those students that screwed up, you at least got a point if you drew a correct picture on this thing. This is the type of stuff that we do on the exam. We never told you to draw a picture, but it's inherent in this kind of a problem. You definitely want to draw a picture anytime you're doing area or volume or whatever. But now, this time, we want to rotate around what? The y-axis. My functions in terms of x, I want to rotate around the y-axis. You guys remember the formula for that method, which is called the shell method? What is it? Volume equals 2 pi times the integral of what I call point radius times top minus bottom dx from a to b. These were my generic formulas that we came up with our class, and I'm sure your professor did the same thing. So, volume, what would be my point radius? From the axis of rotation to an arbitrary xy point inside, anytime you're going around the y-axis, what is this point radius going to be? You got it. Point radius is equal to x, so the volume is equal to 2 pi times the integral from 0 to pi halves of x times, what's the function on top? What's my top function of my region? Cosine of x minus what's the function on the bottom? 0 dx. So in terms of answers that we actually had written down that we were grading off of, the answer we wanted was volume is equal to 2 pi times the integral from 0 to pi halves of x times the cosine of x dx. This is the answer. You did not have to evaluate it, and if I was asked to evaluate it by hand, I would have to use integration by parts on this one. Does that make sense? Did I lose you guys anywhere? Notice, that was a set up the integral but not evaluate it. All right, take a look at this next problem. You know and I know they're going to throw some clearing out of a tank at you guys. Find the work in pumping stuff out of a tank. Make sure you have your forms memorized for this thing. This is a 10-point problem. Don't screw it up. A minimum of a difference between an A and a B. So pay attention to this one. A solid is formed by rotating about the x-axis, the region in the first quadrant bounded above by the curve y equals 1 minus x. Now suppose that the tank is in the shape, is sitting on top of the ground and its circular base, and that the tank is full of water. All the distances are measured in meters. Thus the radius of the base of the tank is 1 meter. Find the work done in pumping all the water out of a tank to the top of the tank. The density of the water is 1,000 kilograms per cubic meter, and gravitational constant is 9.8. That's the metric problem here. Evaluate the integrals involved by hand. And today you're supposed to find a work on this thing. All right. Right there, that nice pause that I hear with you guys right now, I saw that on the test. I saw these people start to sweat, panic, wet themselves, whatever, when they came across this particular problem. Why? They didn't know where to start. Do what you know what to do. It's a work problem. At least write down the formula for work. But remember, with all this volume rotation, including work problems, you need to draw pictures. You got to have a tank. That's where you start. Draw the tank. They didn't draw you a tank. They gave you some kind of weird equation. Let's take a look. A solid is formed by rotating around the y-axis. You're thinking volume rotation problem, but you don't need it. In the first quadrant, bounded by the curve, y equals 1 minus x squared. What does that thing look like? In the first quadrant, I can graph this. If you need a calculator, go ahead, but you shouldn't have to. When x equals 0, y is 1. When I put x is 1, y is 0. So I go through these points. It's an upside-down parabola. That's what it is. So they took this particular curve, and what do they do with it? They rotate it around the y-axis. When I rotate around the y-axis, I'm going to get this reverse image over on this side, and you're going to get this nice circular region. Beehive, if you will. This is the tank that you have. You had to draw the picture of the tank. What's nice was they gave you the equation of the outside edge. Mighty decent of them. You'll need that later. Now, here's the deal. We've got this nice problem here. Now we have the tank full of water. What are we supposed to do? We are supposed to find the work in pumping all the water out of the top of the tank. So the top of the tank is where? 1. This is my target to get the water out of the top of the tank. What was the formula for work? Work was equal to the sum of delta force times distance that you have to pump. What was delta force equal to? Delta force was equal to what I called water weight for my class times delta volume, the slice. Every professor teaches this stuff differently. Some professors have formulas for this stuff. I tried to do what we call project calculus back at NC State when they were working with Duke University and trying to figure out ways of re-explaining calculus that didn't seem to go as well as we would have liked. But nevertheless, this method of setting up the integrals is key. What's the water weight? What kind of problem is this guy? Metric system. Now, they gave you this elaborate, well, the density of water is 1,000 kilograms per meter cubed, and the gravitational constant is 9.8 meters per second squared. That's awesome, dude. What is the water weight? It's gravitational constant, gravity, times density. What do I get? Yeah, you got that one memorized for me, too. It's 9,800 newtons per meter cubed. That's what the gravitational constant is. And where they get it from is the 9.8 times 1,000. All right? But then you got to do, now here comes your analysis. You got to do your delta volume slice. The delta volume slice. So here's your delta volume. I'm going to come up here, somewhere along the y-axis right here, I'm going to make myself a little delta y. And I'm going to make myself a slice. And if I take a little slice out of this thing and pull it over, what does the slice look like? What is it? It's delta y tall. Has a particular radius there. But what's my... It is a what? A disk. What is the formula for the volume of a disk? Pi r squared h. What's the height of this thing? Delta y. What's the radius of this thing? Outstanding. It is x. Why is it x? Because it's on a slant. Anytime your radius is moving away, and here's the part that I'm pulling out here, anytime that part has been moved away because it's on a slant, it's going to change. You're moving away from the y-axis, that's in the x direction. Your radius, because your y-axis is down the middle, your radius is x. Does that make sense? So that gives you delta volume to be equal to pi x squared times delta y. Does that make sense? And that's your delta volume equation. Pi x squared delta y. So work is equal to the sum of the change in force times the distance that you have to pump. So work is equal to the sum of 9,800 pi x squared times delta y. That's your delta force. What would be the distance you have to pump? Well, this was at an arbitrary y level that you made this slice, right? Where are we trying to lift all this water to? 1, the top of the tank. So remember, distances are either top minus bottom or right minus left. That's your big setup. So it's top minus bottom because work is all about lift. That's why I always try to do my functions in terms of y instead of trying to deviate, well, trying to do like the book does, which is tries to convert it to x, which makes it no sense at all. All right, so what is the distance that I have to pump? It is top minus bottom. The target is 1 minus the arbitrary slice I made was y, so the distance is 1 minus y. Converting this to calculus, this turns in summation turns into the integral of 9,800 x squared times 1 minus y. The summation turns into the integral, the delta y turns into dy. And I got a problem. Wait, oh, lost my pi there. Thank you. All right, but I turn my function in terms of y. Now, what's the most important variable within this integration? dy. And I got a problem. What's my problem? Big old x squared in the middle of my y stuff. But that's all right. This is where the edge of the tank equation comes from. The relationship between x and y. What is the relationship between x and y? They gave that to you. Y is equal to 1 minus x squared. I need to sit there and solve for x squared. So I'm going to sit there and add x squared to both sides. and subtract y from both sides, which was nice. This cancels, this cancels. That gives me x squared is equal to actually 1 minus y. Does that make sense? So, this work is equal to constants pull out front, 9800 pi, times integral of x squared gets replaced with 1 minus y, times 1 minus y dy. And what are my bounds? 0 to 1. Okay? Why 0 to 1? Because that's the water. I'm doing dy. The water was at the bottom is 0, and at the top was 1. You only integrate where the water is. Make sure you study this. Now, they did ask me to calculate the work. And this was worth some points. They also said you had to calculate it by showing your work by hand. There's two different ways we accepted the answer. You could have done this. Cleaned up this problem. This would have been work equals 9800 pi times integral from 0 to 1 of 1 minus y squared dy. Because 1 minus y times 1 minus y is 1 minus y squared. If I'm going to integrate this by hand, because I had to show my work, what did I have to do here? What technique of integration would you use to show work? Use substitution. I would let u equal to 1 minus y. That makes du equal to negative 1 dy. Move the negative to the other side. Negative 1 du equals dy. This turns into 9800 pi times integral of u squared. And dy gets a negative du. Negative du. This is 9800 pi. Integral of u squared is u cubed over 3. This ends up becoming negative there. Negative 9800 pi times u was 1 minus y cubed over 3. Evaluated from 0 to 1. Fundamental theorem of calculus, plug in top minus plug in bottom. Negative 9800 times 1 minus 1 cubed over 3 minus negative 9800 times 1 minus 0 cubed over 3. And I lost my pi somewhere. Chuck my pi back there. There you go. All right, what's 1 minus 1? 0. What's a negative? A negative. Positive. 1 minus 0 is 1. 1 cubed is 1. So I get what? That's the answer. 9800 pi over 3. And don't forget your units. What would your units be on a problem like this? It's work. And it's in the metric system. So what is it? Joules. There's what they wanted. However, there was another way you could have integrated this thing. And that is, since it was 1 minus y times 1 minus y, you could have, if you wanted to, is done this. 9800 pi, fold this stuff out. This would have been 1 minus 2y plus y squared dy from 0 to 1. And integrated that guy. This would be 9800 times y minus 2y minus y cubed over 3. I'm sorry, minus 2y squared over 2. Minus y cubed over 3. Evaluated from 0 to 1. And when you plug in your numbers, guess what you got? 9800 pi over 3 joules. Beauty of math. There's only one answer, multiple ways of getting there. Does that make sense? Did I lose you guys anywhere? All right. Does this problem make more sense? And could you imagine people getting very frustrated with this problem right from the get-go? You know something or other. You never leave any problem blank. Write it down. Problem number 4. Yeah, I'll be in my office probably in about 20 minutes.
Okay, I have something across campus, but it's going to last about an hour or so.
Okay.
Maybe a little more. But I'm doing a review at 5.
Okay.
UNCC or CHS, whatever.
I probably won't be in the office at 5. Just tell you what, meet me in my office at 7:15 in the morning.
Okay.
You do that?
Yeah.
And then we'll walk together carrying all that crap.
Yeah.
Thank you. All right. What a surprise. More Riemann sums. But I have a program. That's awesome. And we know you have a program. So if you do this problem and just give me a calculator answer, we took off extra points making us look at that crap. So Make sure you show your work. Here we go. Problem number 4 here says this. Use the midpoint rule with n equals 2 subintervals to approximate the integral from 1 to 3 of 1 over x dx. They didn't ask you to integrate this thing. They asked you to use the midpoint rule. What's the midpoint rule? Well, midpoint rule, n for a midpoint for n, is equal to the sum of f of xi times delta x, where you use the midpoints. Right? So, delta x was equal to, what's my formula for delta x? B minus a over n. So a and b is what? A is 1, b is 3, so it'll be 3 minus 1 over n. What's the number of partitions? 2. So this is 2 over 2, which is equal to 1. So, best way to do midpoint or Simpsons or Riemann sums or any of these guys is draw yourself a number line. What's my bounds? 1 to 3. This is on the x-axis here. This is your partitions. What's my delta x equal to? 1. So if I go from 1, the next number up when delta x is equal to 1 would be what? 2. And another delta x equals 1 would be equal to 3. There are my 2 partitions separated by 1, 2, and 3. We are supposed to use the midpoint Riemann sum. So you have got to pick the midpoint between each interval. What's the number between 1 and 2? 1.5. Okay, granted. And we would have accepted 1.5, or for those people who just love fractions, how about 3/2? All right, and what's between 2 and 3? 2.5. Yeah, great. Which is equal to 5/2. Midpoint. Add them together, divide by 2. So far, so good? So this formula for midpoint for n equals 2 would be the sum of f of your midpoint, which is 3/2, times delta x, plus f of 5/2, your other midpoint, times delta x. What is my function on this guy? What is the function that we're playing with here? Look at your integral to figure out what the function is. What we're trying to integrate? 1 over x. So what is 1 over 3/2, that's my function, times, what's delta x equal to? 1, plus 1 over 5/2 times 1. This is equal to 2/3 plus 2/5, and 2/3, make sure I don't screw it up, so use the calculator, plus 2/5 is equal to 16/15 is what I got. And we would have accepted the answer 16/15. So for those people who love decimals, we would also accepted 1.066666667. This is my midpoint for n equals 2. Does that make sense? Could I have screwed up this problem by doing basic arithmetic errors? You bet. We're all prone to careless error. So I would double check myself because I still got another hour, 45 minutes before the end of the exam. And remember, I'm doing this with major explanation on this stuff. So y equals, I type in my function, 1 over x. I go second quit. I'm going to check my program just to make sure I didn't screw it up. Riemann program. A was what? What's your A value? 1. What was B? 3. And what is the number of partitions? 2. Remember when you use Simpson's rule, it doubles in. But for the midpoint, what do I get? 1.0666666. There you go. I know I got it right. Does that make sense? But now, and most people got that. The only problem with a lot of people was they didn't get that with any work. They got it with the mathematical magic answer off the calculator, which meant they got nothing. You have to show your work. So, part B. Note that the integral from 1 to 3 of 1 over x dx is equal to the natural log of 3. Recall that the error estimate with the midpoint, which is nice. They're giving you your midpoint estimate. You're actually supposed to have this thing memorized. Midpoint was error was less than equal to k times b minus a cubed over 24n squared. If it was the trapezoidal rule, it's the same formula. B minus a cubed over, but what's the denominator? 12n squared. And if it was the Simpson's rule formula, remember that one? It's k times b minus a to the 5th power divided by 180 into the 4th power. Memorize your trapezoid, midpoint, error-bound formulas. All right, keep going. Where, for midpoint and trapezoidal rule, The k is the maximum value of the second derivative. Hard part about this one was figuring out what k was. All right. Determine how large an n we must choose to ensure accuracy to be within 0.001 of the midpoint. All right. First thing you got to do is you got to figure out k. K is equal to the max value of the second derivative over the interval between 1 and 3, because that's my a and my b, 1 to 3. What was my function? 1 over x, which is x to negative 1. What's the first derivative? That'll be negative 1x to the negative 2. What's the second derivative? 2x to the negative 3, which is 2 over x cubed. You need to figure out what the k value is. You had to take the second derivative, welcome back to Calculus 1. Then you had to graph it, it's the easiest way to do it, over your region between 1 and 3. When I plug in 1 into my second derivative, which is 2 over x cubed, 1 cubed is 1, 2 divided by 1 is 2. 1, 2. And when I plug in 3, 3 cubed is 27, 2 over 27, a classic fraction there. And this is what my function looks like between these 2 points. What is the k? What is the maximum value? Value is your y-coordinate of the second derivative. What's the biggest y-coordinate of the second derivative? 2. K equals 2. That's what they wanted. And you had to show them how you got k equals 2. But once you got that, now it's an easy problem. All right, so we want to determine the error. This error, right, is less or equal to k. What was k? 2. Times b minus a, which is 3 minus 1 cubed over 24 n squared. And that's supposed to be less than or equal to what number? 0.001. We're trying to figure out, determine how large n must be. The goal is to solve for n. Read the question. Solve for n. So here we go. Solving for n. Let's see if I can do this kind of math. 3 minus 1 is like 2. 2 cubed is 8. And 8 times 2 is 16 divided by 24 times n squared on the bottom is less than or equal to 0.001. I could reduce my fraction, but I don't care. I'm going to solve this thing. I'm going to multiply by n squared on both sides. So I get 16 over 24 is less than or equal to 0.001 times n squared. I'm going to divide by 0.001, so I'm going to get 16 over 24 divided by 0.001, and that's less than or equal to n squared. Now I'm going to put this on my calculator. Now on my calculator, here I go. Parentheses around my fraction, 16 divided by 24, divided by 0.001, and I get this number, 666.6667. It's less than or equal to n squared. But what do I got to do to solve for n? Take the square root of both sides. And I end up getting n to be equal to, when I do this, the square root of, so you guys can see it there, the square root of the answer there. And what do I get? 25.8198887. However, we do expect you guys to remember the rules. N stands for the number of partitions. So how many partitions do I need? I don't care about any decimals. If I have any decimals at all, I always have to do what? Round up. And remember, with the Simpsons rule, n always had to be even. But with midpoint, trapezoidal rule, left or right Riemann sum, you didn't care. It can be any value. But n had to be even for Simpsons rule. So what's my answer on this problem? You round up, not just because it's 0.8, because it's a decimal. The answer is 26. And honestly, we were looking for grading this thing for 2 things here. So we made it 50-50%. If you found k, you got half credit for this part of the problem, and the other part was finding n. Last problem. Yay. Let R denote the region in the first quadrant bounded by the curves y equals x cubed. Between 0 is less than or equal to x less than 1. All right. Find the centroid of the region. First thing you should do is graph it. What does y equal x cubed look like? Well, it's a cubic graph, so I don't need to know that. It's a big old squiggly thing here. Looks like that. But we're supposed to be in the first quadrant between 0 and 1. And to be bounded in the first quadrant, you know, you're bounded by the first quadrant over here. So here's your x-axis, here's your y-axis. So you're talking about this particular region down here. It's got to be bounded in here. A lot of students screwed that up because they were trying to shade the top region, but that's not bounded. They didn't tell you anything about y equals any kind of number up there. X is between 0 and 1, and it's got to be bounded, so it's got to be bounded by the x-axis itself. So this is the region that we're talking about. Now, here we go. What are you supposed to find? Now, a lot of students messed up this problem in the sense that, and not my students, obviously other people's students, didn't know what a centroid was. Help them out. What's a centroid? Center of mass. And that means you've got to go back and memorize those formulas. Luckily, we got the formulas memorized. Excellent. What is the center of mass? Well, you have to have the mass. The mass by formula is the integral from A to B of top minus bottom, f of x minus g of x dx. Density times area. The moment about the x-axis is the tendency to rotate around the x-axis. That's rho over 2 times integral from A to B of your top function, f of x squared. This is top, this is bottom, in case you get confused. Top squared minus bottom g of x squared dx. And then you had the moment about the y-axis. The moment about the y-axis is rho times integral from A to B of x times f of x minus g of x dx. And where do they come from? The mass is the area formula times rho. The moment about the x is the tendency to rotate around the x. Is actually coming from the dishwasher method. And the moment about the y is the shell method. Moment rotating around the y-axis. That's the shell method. And so your point radius is x times top minus bottom. This is big radius squared minus little radius squared. The pi is the big deal if trying to memorize this stuff. Pi is equivalent to rho over 2, which makes 2 pi equivalent to rho. But the last thing you supposed to have memorized on this thing was this. The center of mass is a coordinate, x bar, y bar. To get the x coordinate, you take the moment about the y and divide by the mass. To get the y coordinate, you take the moment about the x and divide by the mass. This is what they're quizzing you on. The formula is quite simple. And we did not, which was a mistake on our part, tell you to integrate this stuff by hand. So you could have even used your calculator integrator. But you had to set it up. What was the mass equal to? That would be rho times integral of what the function on top is x cubed. But minus the function on bottom is 0 dx from 0 to 1, A to B. So you can clean this up. This will be rho times x to the 4th over 4, evaluated from 0 to 1. Plug in top minus plug in bottom, that's 1/4 minus 0. That is rho over 4. That's your mass. You had to show your work, but you didn't have to show the integral. So if you put that and then gave up with that one, that's fine too. The moment about the x would be rho over 2 times integral from 0 to 1 of your big radius, which is your function, x cubed squared minus little radius, 0, which is the inside part, bottom part, squared dx. But you had to clean them up. So the moment about the x would be rho over 2 times integral from 0 to 1 of x to the 6, power to the power multiplied dx. So this is rho over 2 times x to the 7th over 7, evaluated from 0 to 1. This is rho over 2 times 1/7 minus 0, which gave you rho over 14. Moment about the x. This is the way we honestly anticipated you guys doing it, but a lot of people just used their calculator in it, right? All right, which was fine on this problem. Moment about the y. By formula, the moment about the y is rho times integral of x times the top function, which is x cubed, minus the bottom function, which is 0 dx from your region. X is going between 0 and 1 on my bounds. Clean them up first. So the moment about the y would be rho times integral from 0 to 1 of x to the 4th dx. That gives you rho times x to the 5th over 5, evaluated from 0 to 1. This will be rho times 1/5 minus 0. So the moment about the y is rho over 5. This is what we were looking for to get full credit on the problem. You had to give me all 3 of these parts because you had to show your work. Whether you showed the integration or not, that was honestly up to you guys because they didn't tell us to do that. However, the answer is, what is the centroid? The centroid is the coordinates. X bar is the moment about the y divided by the mass. The moment about the y is rho over 5 divided by the mass, and the mass was rho over 4. Let me put it up here, you guys can read this. Rho over 5 divided by rho over 4. Clean it up, this is rho over 5 times 4 over rho. The rho's cancel. What do you get? 4/5. You get the y coordinate. It's the moment about the x-axis divided by the mass. The moment about the x was rho over 14 divided by the mass, which was rho over 4. This is rho over 14 times 4 over rho. The rho's cancel. You get 4 over 14, which reduces to 2/7. The center of mass, we did want a coordinate pair on this one, was 4/5, 2/7. But the last thing I would do on this particular problem to see if this makes sense. So if I look at this problem, this is the point 1, 1, this is 0, 1. The x is 4/5, so it's somewhere toward closer to 1, and the y coordinate is 2/7. So the center of mass is right about there according to what they gave me. That makes sense. Don't let this be the only exam you guys study. There are a lot more good examples out there, especially with the work problems, center of mass problems, sequence series. But don't forget, about 60% of this exam is going to be integration. Focus on integration. Study hard, and I'll see you tomorrow at 7 o'clock in the morning, 7:30.